Welcome back to your series of solution and explanation to competitive coding. Today we are going to solve LeetCode question number 121, that is best time to buy and sell the stocks. Okay, so let me read the question to understand what the question says. The question says you are given array prices where prices of I is the price of a given stock on the ith day. Okay, so initially we are given like integer array that is called as prices, and each index, like each value is stored in that array at ith position. It tells the amount or the cost of price, the cost of stock at that particular day. Like if we are on the 0 to index, so prices of 0 tell me the price of stock at 0 day, like day 1. Okay, so and following respectively at each day, the indices are containing the price of the stock at that particular day. Okay, so you want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell this stock. Okay, so this is basically kind of optimization problem in which we have to maximize the profit by buying the stock at a particular single day and selling it in future. So here is one constraint we have to keep in mind, that is we always have to buy the stock before we have to sell it. That is, we can't do like we are selling stock now and we are buying it in future. We can't do this, and we have to always buy it before we could sell it. Okay, so this is the one constraint. And return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. Okay, so we have to like return the maximum profit what we could make from the given list of prices, and so that we can buy stock and then we can sell it in future. And if we can't make any profit, we have to return 0 instead of negative values. Okay, so if like we can't make any profit, we don't have to do transaction for our losses. Oh, so that in that case we have to return 0. So let me see the examples. What does the example say? So first example is that input of prices. So prices array contains values like 7, 1, 5, 3, 6, and 4. So in this we have to return 5, and how we can return 5 is that we don't have to like buy the price on the first day. We can buy the price on the second day, and then we can sell the price for the third day, which would give us profit of 4. Then we can buy sell our like stock on the fourth day, which would give us profit of 2. But this is not the maximum, so we consider 4 as a profit. Then we can sell it on the fifth day, that is 6, and this would give us 5 as a profit. And we can even sell it on the like last day, that would give us 3 profits. So we have to take the maximum of those profits. So 5 is the maximum profit, so we have to return the 5. Okay, so we have to purchase on the like buy the price on the second day, and we have to sell it on the fifth day to make the maximum profit. Okay, so this is what the explanation is saying. Okay, so in the example number 2, we are given the prices array of prices that is decreasing like on every increasing day, like on every next day the prices are decreasing and they have never increased, so that we don't have to do the transaction for our losses. We have to return 0 because we can't make any profit in this situation if the prices are like decreasing low by low. If we initially buy the stock, then we can't sell it at our losses. So in this situation we have to return 0, and we don't have to make losses for our stocks. Okay, so there are two constraints given, that is prices of length would always be between something 1 to 10 to the power 5, and the prices would be something 0 to 10 to the power 4, so we don't have to take care of like negative prices. So let us jump into our explanation board and see what we can do from this. Okay, so these are two examples I've taken from the same examples given in the question of LeetCode. Okay, so initially, the brute force approach to solve this question would be something like we can check for like all the pairs that what maximum profit we could make by initially buying the stock and then selling it in future. So brute force approach tells us that we can do is, suppose we start from here and whatever day we have buy the stock, we can't sell it on the same day because we won't make any profit, because the today's price is the same, and if we like buy on the same day and we sell on the same day, we won't make any profit. Okay, so we have to always check for the future that if we could make any profit. So in this situation we have to iterate over the whole array to check all the pairs, which pair is given like the maximum profit. The brute force approach tell us to solve the question. Okay, so we could do is that we like you start from the index 0 and then we move further to check if we can make any profits. Then we see that we can't make any profit because it is giving us negative value. If we buy the stock for price of 7 and we sell at the price of 1, we have to make a loss of 6, or we can say that we are making a negative profit of 6, and that we don't have to provide like generate negative values. And then we move further and we check if this index like this prices or the value at this index is also giving me negative values. Then we move further and check if this is also giving negative value, and we keep on moving further and check the whole array, and we found that all the prices are like all the future prices are giving me negative value. So we keep our maximum profit up to 0 and we don't update our maximum profit. So we are actually using one counter to store our maximum profit, max profit, and the other counter to check like like consecutive, like if you could make the profit from this one. Like any like value at any index. Okay, so we move further and we start checking for like from second index, like we are considering all the pairs. Okay, so if we start from here, so our purchasing or buying value is 1 now, and we move further and we found that yeah, we can make any profit. So we have to do it, what we have to do is we have to update our maximum profit from like 0, what is we have up till now, to our like differences between the uh, selling and buying of stocks. Okay, so this is basically 4, this is giving me 4, because if we buy it for 1 price and we sell it for 5, we can make a profit of 4. So up till now our maximum profit is 4, and as we move further and we check this, that this time we can also make a profit by selling the stock, but this profit is lesser than what we have already made, so we don't update our like maximum profit and we keep it up to 4, and we move further and we check this at this index we can also make a profit, because our like buying value is lesser than the whatever the value is present in this index. So and we check what profit we can make, and we found that we can make a profit of 5, and then we'll update our like maximum profit, because this one is greater than our previous maximum profit. And then we move further and we check this index also gives us profit, but that profit is not maximum, and we have to maximize the profit, so we don't consider this index and we keep our maximum profit as 5. So up till now our maximum profit is 5, and we keep on moving and checking for each pair that are present in our array, and we start from like second index or like third index from second, from 2, and we start checking from this index and we move further that at this point we can't make any profit, and if we move further at this point we can make profit of 1, but still our maximum profit is 5, because we have already made a profit which is greater than this profit. And we move further and we check like at this point we can't make any profit, and we are done with this iteration. Then we move to next iteration, buying the price of like stock at 3, and then we can sell it for like 6. Then this situation is also giving me a profit of 3, but we have already profit that is greater than value of 3, so we don't consider this one. Then we move further, this situation is giving me the value of 1, which we again don't consider because we have already the greater value for maximum profit. And then we are moving to last iteration, that is buying the stock for 6 and selling it for 4. This gives me negative profit, so we don't consider this one. So overall our profit is 5 now, what we have already seen in our example. So this situation is giving me profit of 5. The brute force approach gives me the correct profit of 5, what we have seen in our example in our LeetCode question. Okay, so let me apply this same approach in our negative values or monotonically decreasing values and see if it would work or not. So our maximum profit initially is 0, because we'll assign it to 0, because if we can't make any profit we have to return like 0 as our maximum profit. Okay, so in this situation we also have to initially initialize it with 0, and like after iterating over the arrays again and again, like checking all the pairs, we can update it to 5, because this is what we have obtained from our iterations. Okay, so for this case we started from here and we keep on moving, but and get each time we are getting that we are making negative profits. Actually in each index we are checking that we are getting negative profits, so overall profit is our 0. And then we start from second index and checking for the remaining pairs, and we keep on checking and getting the same situation, all zeros, all negative values. Then again our maximum profit is 0. Then we start from third index, keep on checking for each successive indexes, and we found again we are getting negative values, and so overall profit up till now is 0. Then we move to the last pair, to check if they could generate some profit, and we check again they are giving negative values, so we have to return 0. So up till now our profit is 0 and we have to return 0 because in this situation we can't make any profits. So, but this approach is like checking all the pairs approach is like O of n square, which is a kind of not accepted for the large indices, for the large size of arrays. This is unacceptable. So we have to make it better. And how can we make it better? Let's see. How can we make it better? So let me remove this all. Okay, so I'm going to remove this all to. Okay, so we are done with that. So our better approach says that what we can do is that we can initialize. There are actually two better approaches. Oh, okay. So let me see for the first one. So we are now using not only our maximum profit array, okay, maximum profit counter. We are using maximum profit with like a minimum value. Okay, min value. Okay, so we are having like two we are using two pointers. Okay, one will keep the record of our maximum profit and other will keep the record of our minimum value up till now. Okay, so what this algorithm says is that you have to buy the stocks in the minimum price and sell it in the maximum price to gain the maximum profit. Like you have to keep that condition in mind that you have to always buy before you have to sell it. Okay, so what we're going to do is maximum profit is initially 0. We start from here. We assign some negative large values, like infinity large values to this minimum value, and we keep on checking at each step if like our minimum value, like min value, let me write it as min. Okay, like our min value is if it is greater than our element at current index, then we update our minimum value to that value. Okay, so when we move to here, like when we move to, or when we get to our first index, we found that this value is larger than our element at first index, so we update our minimum value to 7. Okay, so now our minimum value is 7, and because we have just to buy our stock at 7, so we can't sell it. Then we have to move further and check. First thing we have to check is that if we can reduce our minimum index, then we check, yeah, our minimum index value is greater than our current index value, so we have to again update our minimum index. Now our minimum value is this index, and if we have already updated our minimum index, we don't have to calculate the profit, because if we have like purchase or buy the stock at a particular day, we can't sell it, because if we sell it on the same day, we are making a profit of 0. Then we move further and we check if the like element at this index is greater or smaller than our minimum value. We found that this index is greater than our minimum value, so we keep our minimum value as 1 and we don't update it. If we are not updating our minimum index value, then the next thing we can do is that we can check for our profit, that whether we are generating profit for this index or not. And we found that for the difference between like the present price and whatever the minimum value is 4, and we found that we can make a profit of 4 by selling the stocks. So we update our minimum profit to from 0 to 4. Now our minimum profit is 4. And we move further and check for the rest value. First thing we are going to check is that if this is lesser than our minimum value, we found this is not lesser than our minimum value. Then if this is not like lesser than our minimum value, we have to check whether we can generate the profit. And if the profit is greater than the profit, maximum profit what we have obtained up till now, then we are going to update our maximum profit. But at this index, we found that this is not minimum than our, like this is not smaller than our minimum value. Then we are not going to update this with the minimum value. And the second thing we are checking is that if we are generating profit, yeah, we are generating profit. Is this profit greater than our like previous like up till now maximum profit? No, it is not. So we are not going to update our maximum profit too. So we are keeping it same up to 4. And when we move further, we check for the same situation, like if this is the lesser than our minimum value, it is not. Then we are going to check if we can make profit. Yeah, we can make profit. And if this profit is greater than our maximum profit up till now, yeah, this one is greater, then we have to update our maximum profit from 4 to 5. Now our maximum profit no longer remains 4, it will become 5 now. And we move further and check if this is minimum, like lesser than our minimum value. Again, it is not. If we can generate profit, yes, we can generate profit. And if this profit is greater than our maximum profit up till now, no, it is not. So we keep our maximum profit for the entire like iteration, and we found out that 5 is our maximum profit, and which we have already obtained from brute force approach, and this one gives me correct answer. So our maximum profit for the this situation will be generated as 5, and we can return our maximum profit in the end of array, and which is the correct answer actually. Let me check this if this algorithm works for like monotonic decreasing array, and we start from the index like 0 and we mark it as minimum value, and as we move further, and we first thing we have to check if it is lesser than our minimum value. We found is, yeah, this one is lesser than our minimum value, so we have to update our minimum value from here to this one. Minimum value will become now this one, and then we move further and check if this is our minimum lesser than our minimum value. So then we found that, yeah, this one is also lesser than our minimum value. Then we have to update our minimum value to this one. Okay, so now this will become our minimum value. Then we move further and check if this is lesser than our minimum value. We find again this is lesser than our minimum value. Then we are again going to update our minimum value. So our minimum value is now the 3, and again we move further and check whether this is lesser than our minimum value. Again we check, yeah, this one is lesser than our minimum value, so we are going to again update our minimum value. So we are on the last index, and we didn't make any transactions because we are in the process of finding minimum value, and we found that this one is minimum value. So our maximum profit, which is initially 0, will remain always 0, and we have to return 0, which is actually the correct answer. So let me actually it has one more approach, that is traversing from the back. That is what we can do is we can actually check from the back, that is like this is the maximum sale what we have made, and we can go back that check if it is maximum sale. So yeah, if this increases, we have to update our maximum sale, and if this increases, we have to update our maximum sale. If this increases, we have to update our maximum sale. Again, if this increases, we have to make our maximum sale. And whatever maximum sale we did is we are going to check with whether we can make profit, like whether we have make profit by purchasing it in like past and selling at a particular day. So maximum sale in this case will be 7, and we can't purchase it before because it is at index 0. For this situation, we can do is that, yeah, this situation would give us like perfect answer, because suppose we are our maximum purchase is this one, and we have to generate our maximum purchase for like greater than 0, because we can't make our maximum purchase for the 0th index, because if like maximum sale at 0th index, because we can't sell on our 0 index. So our maximum sale for this situation is like 4, and we can check like if we can make profit for the 4, and we keep on moving and we keep moving. We go here, if we can, like if the maximum sale increases, we check, yeah, maximum sale increases, so we make this one our maximum sale. And if we are making sale, we can't purchase on the same day, so we have to move backward. At this point, we check that if like our maximum sale increases, we found that maximum sale didn't increase, it remains 6 as same before. Then we can check if we are making profit by making like maximum sale minus the element and that in this index. We found that, yeah, we are making profit of 3, so our maximum profit will go from 0 to 3. So our maximum profit will be now 3, and then we move again like backward, and we can check if this is a maximum sale. Then we found that this one is not a maximum sale because we have already having greater value than this element. Then we can check if we are making profit by like maximum sale minus this element. Yeah, we are generating profit, but that profit isn't greater than whatever profit we have already made. Then we again move backward and check if this is our maximum sale. Then we found that no, we don't, because we already have a greater element at our maximum sale. Then we are going to calculate for our profit, and this profit will give me 5, so we can update our profit from 3 to 5, and then we are done, because we can't check for like, and when we have to go for like checking last element if this element is giving me greater profit, but we can't update our element to maximum sale for this time. Okay, so these are two approaches which are of order of n time and order of 1 space complexity. So let me code the solution to give you a better instance or better idea of these. So let's now code it. Okay, so initially we have to take two like pointers or two variables to store our minimum value and maximum profit. So we can do is that integer, we can say it as min val something to store the minimum value, and initially it is like you can assign it like some great values to each integer dot max value. Okay, so this is holding like some great values, and this is like that. Okay, so next thing we are going to store is that maximum profit. That is our max profit, and initially it would be 0 as discussed in the explanation. Okay, so now we are going to iterate over our array to generate the maximum profit. Okay, so for 90 I equals initially 0, and then I can say I is less than prices of length PNG, my bad, length, and the third thing I can do is I plus plus. Okay, so now we are going to check if like first thing we have to check is that if our min value is greater than our current value, like the value at the present index. So if our min value, okay, my bad, min value is greater than our current value, prices of I, then we have to update our min value. Okay, so our min value will be now, min value will be updated from, okay, min value will be prices of I. Okay, but if this is not the situation, that is our min value is not greater than, then we have to check if we are good generating more profit. Like if the max profit is lesser than the current value minus min value, prices, prices of I minus min value, then we can update our maximum profit, to our prices of I, prices at I minus min value. Okay, and then we can finally return our max profit, return max profit. Okay, let me see if it works or not. Okay, so it worked. There are no typos, and it did work. So let me submit our code to check if it is valid for all test cases and if it is optimal or not. So it seems to me an optimal solution, and I would like if you would code the other approach of what I've told you in the explanation, and hope you understand what the explanation as well as the like problem and statement and the solution, and enjoy learning, and thanks for watching as always.